So what is high voltage engineering?
So high voltage. So let's say why we need high voltage at all. So we know that we need electricity, and electricity power is a product of both electric current and electric potential difference. So why we need high voltage historically, which Nikola Tesla was pushing for, and now we have it all over around the world, is the transmission line. So when you increase the level of voltage, when you're transferring power, you can reduce, like, you can think of it that way. So you have a certain level of power, and you can reach that power either by voltage or by current. So if you increase the current instead of voltage, you're going to increase the size of conductors, like your wires need to be thicker. Higher thickness means more copper, means more expensive and more space that you need to devote. But with voltage, you can reduce the current and make things smaller. But high voltage usually leads to higher electric tension, which we call electric field intensity. And that can cause a lot of problems. Like some people might have heard like a hissing sound when they're in the proximity of transmission lines. And that's from a phenomenon called corona discharge, which is because of the high voltage. So now high voltage has a lot of applications because of the same reason. The electric aircraft that we are envisioning for future is going to use higher levels of voltage than we currently have, because we want to reduce the size, we want to increase the power density, and we'll push for higher voltage. And with our company, Avalanche Energy, we push that to crazy, like 300 kilovolts we have in a device. 300 kilovolts, to put it in like a comparison mode, so our house uses 120 volt output. So 300,000 volts, I mean, I think 1,000 times or 3,000 times higher voltage. So it's very dangerous, but it enables a lot of good things too.